Hey everybody, good morning. Welcome to day one of chapter 6, acid-base chemistry. So for this chapter, we're going to spend, if you've read the weekly outline, we're going to spend 2 weeks on chapter 6. This is our last big one. After chapter 6, we have 2 small chapters left. They will each take probably a week each, roughly. So we're looking at being done pretty early in June. We won't be going right till the last day of classes, that's for sure. We've been rolling along at a good pace. So what we're going to be doing today is properties of acids and bases, and then you guys are going to learn how to write acid-base reactions. That'll be a little bit new for you. In this chapter, by the end of it, you can look at pretty much any chemical compound and decide whether it's an acid or a base, show how it acts as an acid or a base, and if you're given its concentration, you can calculate its pH as well. So that's the goal. First thing we're going to start off with. So you've got your notes handout that you printed out from, I sent it out in today's lesson. It's compressed, so you don't have to use many pages. I think it's like 8 or 9 pages for all the notes for the chapter. And you've got this chart to fill in. So these are properties of acids and bases that you probably learned in grade 10. So bases taste bitter. So soaps are good examples of bases. And actually, I'm going to tell you a funny story. When my nephew was in grade 4, this is my sister-in-law's son, Joey. When he was in grade 4, he learned the F-bomb at school. And so he came home, and my sister-in-law was putting a casserole out on the table for dinner. And he didn't like casseroles, and he looked at it, and he goes, "What the F is that?" And she was so shocked. She's like, "Oh my God, Joey Gelden Patterson." And she grabbed him by the arm and marched him into the bathroom and shoved a bar of soap into his mouth. And then he was leaning over the sink and he was spitting into the sink, gagging and washing the soap out of his mouth. And he looked up at her and he goes, "What the F did you do that for?" So apparently she needed to explain the punishment. He didn't realize that F-bombs aren't really appropriate at home or at school. Anyway, that joke always pops in my head when I talk about soaps. So bases taste bitter and they feel slippery. Soap is a classic example of a base. So what about acids? Well, acids are the opposite of bases. So if soaps taste bitter, acids taste sour. And I would ask you to do this with your hand, but they have a grippy texture. So they're not slippery, they're grippy. Okay, acids turn blue litmus red, which means they turn red litmus blue. Okay, bases have a pH greater than 7. Acids are the opposite. pH less than 7. Okay, acids neutralize bases. Well, that means that bases neutralize acids. Makes sense. Everything's opposite. Okay, next column. That's unfortunate. It's covered, and I have no idea what it is. Acids react with carbonates to produce carbon dioxide. Oh, right. Acids react with metals to make hydrogen gas. React with metals to make hydrogen gas. Okay, so you need to know all those properties of acids and bases. Okay, now this next table, this is a skill that you should have by the end of the chapter. You should be able to look at a compound and predict whether or not it is acidic or basic. So just for fun, I'm going to get you to pause the video here, and you're going to look at this list and you're going to write down acid, base, or neutral. So calcium chloride, an ionic compound. Do you think it's acid, base, or neutral? So you're just going to write it down. I'm going to predict this first one. I'm going to call it neutral. And then when you come back, we'll do the actual. What are they really? So just take a minute, go down this list and predict acid, base, or neutral for each one. Pause the video while you do that. Okay, so you've made your predictions. Calcium chloride is a neutral ionic compound. When it breaks apart into calcium 2+ and Cl-. From our last chapter, those are the major entities present. There's no acidic or basic properties in calcium chloride. Okay, this next one, C3H4OH, COOH3. What did you predict it as? It is an acid. I should write neutral here. Okay, why is it an acid? Because when it breaks apart, we get C3H4OH, COOH2, and the third one breaks off an H plus and a COO minus. And I'm just going to switch to red. There's the acidic part. Okay, C6H12O6, what do you think? Well, if you know that one, you know it is glucose. It is a molecular compound. It will just stay together as C6H12O6, and it is neutral. Okay, CaOH2 is an ionic compound. It will dissociate into calcium 2 plus and 2 hydroxides. And hydroxides are basic. I'm circling the bases in blue and the acids in red. Okay, NH3. NH3 is a molecule that stays together. But what NH3 will do is it actually attacks water. It'll react with water to make NH4 plus and OH minus. And OH minus is a base. Wow, that's tricky. So ammonia is considered basic. In water, it can create hydroxide ions. Tricky. Okay. Next one is, come on, move. Won't get rid of that. Okay, we'll do that. NaHSO4. So that's ionic, breaks apart into Na plus, HSO4 minus, and HSO4 minus is capable of giving us an H plus and an SO4 2 minus, and that H plus is acidic. Now you might be looking at these going, holy smokes, how's he doing this? I don't know all of these. Don't worry, you don't have to yet. We'll learn them by the end of the chapter. You should be able to do this. CH3OH, this one fools a lot of students. They see the OH and they go, oh, it's a base, but it's not because it's a molecular compound and molecular compounds stay together, so it's neutral. It is only ionic hydroxides that are basic. So that one is ionic. This one is molecular, so different properties. Ionics can dissociate. Moleculars cannot, they just dissolve. So all this one does is dissolve as aqueous, whereas this one dissociates, which gives us the OH minus. Basic. H2SO4, you might recognize that one. Hopefully you predicted it. It is an acid. It breaks apart into H plus and HSO4 minus, and in fact, that is one of the big 6 strong acids. SA, strong acid. So it makes 100% H plus. And this last one's tricky. It's an ionic compound. We break it apart. There's 2 Na plus and a CO32 minus. And the CO32 minus can react with water to make HCO3 minus and OH minus. OMG, another base. So carbonate ions are basic because they too can react with water to make OH minus, the same as NH3 is a base that can react with water to make hydroxide ions. So those ones are tricky, and I wouldn't expect you to know those. And what a mess I've made on the slide. Breaking all those apart, reacting them with water. So that's where we're headed. By the end of the chapter, you'll be able to successfully predict all those compounds as acidic, basic, or neutral. Okay, some simple tests for acids and bases and moleculars and ionics. We've reviewed this already, so this is quick for you. Molecular compounds are neutral, most of them. In water, their conductivity is none or no conductivity. They do not form ions. And if they're neutral, they have a pH of 7. Ionic compounds do conduct, so we would say they have high conductivity. And if they have no effect on litmus paper, their pH is also 7. Acids. So acids ionize, they turn into ions, which means they will have high conductivity and their pH is less than 7. And bases also dissociate. So acids ionize and bases dissociate. The net result of both of those is you get ions. And if you get ions, you have high conductivity, and bases have a pH greater than 7. Okay, so those are diagnostic tests for 4 different types of solutions. And now we're moving on to the meat of today's lesson. So you guys are going to learn the modified Arrhenius definition. Arrhenius is the last name of Svante Arrhenius, who was a Swedish chemist who came up with the idea that acids are defined as any substance that can react with water to produce hydronium ions. Hydronium is H3O+. So hydronium is like a water molecule that has gained an H+. H3O+. Sometimes we say that H+ is the same as H3O+, because in water, if you have H+, in water, you have H3O+. So they're kind of interchangeable. Often in Chem 20, we'll write H+, and in Chem 30, we write H3O+. But truly, you can interchange those two. This is showing you that reaction there. H+ and H2O makes H3O+. Okay, so to make H3O+, you are defined as an acid if you can react with water and give it that H+ ion to make hydronium. That's the modified Arrhenius definition of an acidic compound. So, skill 1. And we're going to finish off the lesson today by doing some reactions of acids with water and then some bases. Show how the following compounds could react with water to produce hydronium ions. So it's pretty simple. You take the substance, you add water, H2O, and you react it with water by adding an H+. So you draw the little arrow and you put an H+. So the H+ leaves the HF. So if H+ is gone, F- is left over, fluoride ion. And the H+ joins the water to make hydronium. It's that simple. Okay, modified Arrhenius. I'll do one more. HNO2 reacts with water. I should put water is a liquid. Again, draw your little arrow. Show the H+ being transferred. So we get NO2-, it's lost an H+, so it's lost an H, it's lost a plus, so it's at minus, and hydronium, H3O+, aqueous. Okay, NH4+, this one's a little trickier. So if it loses an H+, it's NH3, and its charge is neutral. It lost a plus. It was plus. Now it's neutral. NH3 has lost an H+, and the water has gained it to hydronium. So what does that show us? It means that all of these are acids. Why are they acids? Because they are all making hydronium in the presence of water. So according to Arrhenius, they are acids. Okay. H3PO4 and H2SO3. I'm going to pause the video and you try these two on your own. See if you can get them right. Okay, same pattern. React it with water. Liquid water. Transfer the H plus. So H3PO4 becomes H2PO4. It was neutral. It lost a plus, so now it's -1. H2PO4 minus. Water gains the H plus, so it becomes H3 instead of H2, and a plus. Aqueous, acidic. And the last one, H2SO3, gains an H plus. So if H2SO3 loses it, it becomes H1SO3 -1, was neutral, and hydronium, H3O plus. Boom. So those are Arrhenius acids, or modified Arrhenius acids. Hey, we're almost done. And now we're going to look at bases. So according to the modified Arrhenius definition, bases are substances that react with water to produce hydroxide ions. Now they can do it two ways. They can dissociate in water to make hydroxides, or they can react with water. So here's an example of ammonia reacting with water. And if you remember, an acid donates an H plus, a base accepts or takes the H plus from water. If you think about it, water is really made up of an H plus and an OH minus to make HOH. So if we remove the H plus from water, we are left with a base, OH minus. So any molecule that can steal the H plus from water can form a basic solution. So that's exactly what ammonia is doing. So that's one group. The other group is ionic compounds that already contain hydroxide ions. So we call them ionic hydroxides. And they just simply dissociate or break apart and give us the OH minus that was already there. And calcium hydroxide gives us two OH minuses. We generally call these strong bases because when they dissociate 100%. So if we had 3.4 molar NaOH, we're going to get 3.4 molar hydroxide. So that's what a strong base does. Ionic hydroxides are strong bases. Okay. Show how the following compounds could react with water to produce hydroxide ions. I'm just going to scan down the list. Okay. So we got 5 of these to do. That's it. Easy peasy. Okay, NH3, we did that one already up above, so we'll skip it. PO4 3 minus. Okay, so again, it's always easiest if you draw the arrow. So if it was an acid, it would be donating a proton. As a base, it's accepting or stealing a proton from water. So the arrow goes the other way, from water to the base. So PO4 3 minus gets an H, so it becomes HPO4. It was 3 minus, now it's 2 minus because it gained the plus. And water has lost an H, so it's down to OH, and it's lost a plus, so it's a minus. Now, as a double check, you always check your charges to make sure they're balanced. So if we look at our charges on this, we have a 3 minus and a neutral. So we're at a total of 3 minus. And on this side, we've got a 2 minus and a 1 minus for a total of 3 minus. So we did it correctly. The charges are balanced. Okay, SO3 2 minus. Same deal. Takes an H plus from water. So if it takes an H plus, it gets the H. So that's HSO3. It took a plus, so instead of 2 minus, it's 1 minus. Water's lost the H plus, so it's down to an OH minus. Check those charges. 2 minus on this side, water is 0. 1 minus, 1 minus, we're at 2 minus. So charges are balanced, we did it correct. And this is what makes these basic solutions. Basic, basic. So we can call PO4 3 minus a base, and we can call SO3 2 minus a base as well, using the modified Arrhenius definition. Okay, HS minus. Try this one on your own. Pause the video, try it. Gains an H plus to become H2S and OH minus. Aqueous. Aqueous. And there's our base. And now this one's tricky. You don't have to react it with water. It just dissociates. It's an ionic hydroxide. There's our base. So remember, for ionics, all you do is dissociate. You don't need to go through a reaction with water like you did for these 3 molecular compounds. So moleculars react, ionics dissociate. You get the same end result, hydroxides every time. Okay. So to practice this in your study guide, page 212 for Johnson, page 216 for Kelly, properties of acids and bases, only do 1, 4, and 5. And it says only analysis part. Just identify the 4 compounds. So you'll understand when you look at those questions. That's a pretty short assignment. And that's it. We're done for the day. Okay, important that you dig into acid-base chemistry. This is Chapter 5, Chapter 6 are the 2 most important chapters for being successful in Chem 20, along with stoichiometry. So this one's really important. I will help you work through the chapter. You will be successful if you put the work in and stay on top of it. We'll be done this one in 2 weeks. So dig in, do your best job, and I'll see you guys tomorrow.